Most thunderstorms are brief and unremarkable, passing overhead with little more than a rumble of thunder and a quick burst of rain. They come and go, barely noticed by most people, simply part of the natural rhythm of the weather. But some storms are different, bigger, stronger, and far more organized. These are the storms that capture our attention, the ones that make us stop and stare at the sky in awe and sometimes in fear. These are the supercells, the kings of all thunderstorms. They are the giants of the storm world, towering high above the landscape and dominating the horizon with their immense size and power. A supercell is a rotating giant, capable of traveling for hours and unleashing the most violent weather on Earth. Tornadoes that can level entire towns, hailstones as large as baseballs, and winds strong enough to uproot trees and flip vehicles. What sets a supercell apart is its deep, persistently rotating updraft called a mesocyclone. This powerful column of rising air is the engine that drives the storm, giving it both its strength and its longevity. This rotation acts like a spinning top, powering the storm and allowing it to sustain itself far longer than ordinary storms. The mesocyclone is what makes supercells so unique and so dangerous. Inside a supercell, warm, moist air is drawn upward and begins to spin, while cooler air descends in powerful downdrafts. This complex dance of air currents creates the perfect environment for severe weather to develop, sometimes with little warning. Supercells are most famous in Tornado Alley, Oklahoma, Kansas, Texas, where the flat land and clashing air masses create ideal conditions for their formation. But they can form anywhere the right ingredients come together. From the vast pampas of Argentina to the remote outback of Australia, and even in parts of Europe and Africa. Their presence is a dramatic reminder of the immense energy in our atmosphere. The sky comes alive with lightning, thunder echoes for miles, and the air itself seems charged with electricity. Recognizing the signs of a supercell can mean the difference between safety and danger. A lowering, rotating cloud base, a sudden shift in wind, or an eerie stillness can all be warnings that something powerful is approaching. I've witnessed these storms firsthand. The sky turns an unnatural shade of green, the wind shifts direction, and a heavy, tense silence falls before the storm unleashes its fury. The raw power is unforgettable. Lightning splits the sky, thunder shakes the ground, and you realize just how small you are in the face of nature's might. It's a humbling experience that drives our research and forecasting. Meteorologists and storm chasers dedicate their lives to understanding these storms, gathering data in the field and analyzing every detail to improve our predictions. By understanding supercells, we can improve warnings and help keep people safe. Early alerts and accurate forecasts save lives, giving communities precious minutes to take shelter. These storms demand respect, and knowledge is our best defense. Communities that know what to look for and how to respond are far better prepared to face the threat. Supercells are not just a meteorological curiosity, they're a real threat to communities everywhere. Their destructive potential is a sobering reminder of why we must never underestimate the power of nature. Their organization and power make them uniquely dangerous, capable of producing multiple tornadoes and severe weather events in a single outbreak. Studying them helps us prepare for nature's most extreme events. Every new discovery brings us closer to understanding how these storms work and how we can stay safe. The more we learn, the better we can protect ourselves and our loved ones. Preparation and awareness are key to surviving the worst that supercells can bring. Supercells are the ultimate test of our understanding of severe weather, a breathtaking display of nature's power, and a challenge that continues to push the limits of science and human resilience. Supercells are among the most powerful and dangerous types of thunderstorms on Earth. They bring four major threats, each with the potential to cause widespread devastation and change lives in an instant. These storms can leave entire communities in ruins, with homes, businesses, and infrastructure suffering severe damage. The most infamous threat is the tornado. Most strong and violent tornadoes are born from supercells, as the storm's rotating updraft, called a mesocyclone, sometimes tightens into a powerful, ground-reaching funnel. These tornadoes can carve paths of destruction miles long, flattening everything in their way. Next is giant hail. The supercell's intense updraft suspends hailstones high in the storm, allowing them to grow larger and larger, sometimes reaching the size of baseballs or even softballs before crashing down to Earth. These massive hailstones can shatter windows, destroy crops, and cause serious injuries. Straight-line winds are another major danger. When powerful downdrafts slam into the ground and spread out, they can topple trees, rip roofs from buildings, and scatter debris over wide areas. These winds can easily exceed 100 miles per hour, rivaling the strength of weak tornadoes and causing widespread destruction in just minutes. Finally, supercells can unleash torrential rain, dumping several inches of water in a very short time. This can lead to flash flooding, which overwhelms rivers, creeks, and urban drainage systems in minutes, turning streets into dangerous rivers. Floods are often underestimated, but they kill more people each year than tornadoes or lightning combined. The force of moving water can sweep away cars, damage homes, and put lives at risk. Never attempt to drive through flooded roads. Just a few inches of water can float a vehicle, and the current is often much stronger than it appears. Each of these threats can strike with little warning, giving people only moments to react and seek shelter. Understanding the dangers of a supercell and preparing ahead of time is key to staying safe when one approaches. Always have a plan, stay informed, and respect the power of these incredible storms. Supercells are among the most powerful and complex storms on Earth, and their formation requires a rare combination of atmospheric ingredients coming together at just the right time and place. The first key ingredient is instability. Imagine warm, moist air pooling near the ground, while much colder, drier air sits high above. This sharp contrast creates a highly unstable environment, primed for explosive updrafts that can shoot skyward with incredible force. The second crucial factor is wind shear, a change in wind speed or direction as you move higher in the atmosphere. Wind shear is what gives supercells their unique, rotating structure. Picture winds blowing from the south at the surface but shifting to the west as you go higher. This difference causes the air to start rolling horizontally, like an invisible tube spinning in the sky. When a powerful updraft punches through this rolling air, it tilts the spinning motion upright, creating a rotating column called a mesocyclone, the heart of every supercell. The rotating updraft becomes separated from the downdraft, which means the storm's fuel supply, warm, moist air, remains uninterrupted, allowing the storm to keep growing. This unique structure lets the supercell sustain itself for hours, drawing in fresh energy and unleashing some of the most severe weather on the planet, including giant hail, damaging winds, and even tornadoes. Instability provides the explosive power, while wind shear gives the storm its signature spin and organization. Only when both of these ingredients are present in just the right amounts does a supercell form, setting it apart from ordinary thunderstorms. The result is nature's most formidable storm engine, capable of dominating the sky and transforming the landscape below. While ordinary storms quickly rain themselves out, supercells can persist, intensify, and even spawn multiple rounds of severe weather. That's why supercells are not only dangerous, but also endlessly fascinating to meteorologists and storm chasers alike. At the heart of every supercell is the mesocyclone, a massive rotating column of air stretching miles wide and high. This rotation organizes the storm, pulling in warm, moist air and fueling its intensity. The mesocyclone's powerful updraft can reach speeds over 150 miles per hour, supporting giant hail and tornado formation. On radar, meteorologists spot mesocyclones as distinct velocity couplets, a clear warning sign. The rotation also creates the classic hook echo on radar, often where tornadoes form. By separating the updraft from the downdraft, the mesocyclone keeps the storm alive and dangerous. This organization is what makes supercells so destructive and long-lived. The mesocyclone is the storm's engine, and its greatest threat. The recipe for supercells is sensitive to climate change. As the planet warms, the atmosphere holds more moisture, increasing instability, the fuel for storms. But wind shear, the ingredient that provides spin, may decrease in some regions. This creates a complex puzzle. Will more fuel outweigh less spin? Research suggests the answer varies by region. In the US, Tornado Alley may shift eastward, putting more populated areas at risk. Severe weather seasons could start earlier or last longer. Climate change isn't just about rising temperatures, it's about shifting weather patterns and risks. The balance of ingredients for supercells is changing. Some areas may see more storms, others less. Understanding these shifts is crucial for future preparedness. Supercells aren't just an American problem. Europe's storm risk is changing too. New research shows Central and Eastern Europe, including Germany, Poland, and the Baltics, will see more supercell-friendly conditions. millions could face greater threats from hail, wind, and tornadoes. Meanwhile, Spain and Portugal may see fewer supercells as wind shear decreases, despite more heat and instability. The atmosphere's dynamics are shifting in complex ways. Not everywhere gets stormier. For Europe, risk is being redistributed. Communities in rising risk areas must adapt building codes, warning systems, and public education. Preparedness is key as the storm map changes. CAPE, Convective Available Potential Energy, is the fuel for thunderstorms. It measures how much energy is available for a storm's updraft, like gasoline in a tank. High CAPE means explosive storm growth. Low CAPE means weak storms. CAPE is created by warm, moist air at the surface and cold, dry air above. When CAPE is high, updrafts can reach over 150 miles per hour, supporting giant hail and towering storm clouds. Without enough CAPE, a storm can't become a supercell. Meteorologists watch for high CAPE to signal dangerous storm potential. As the climate warms, average CAPE values are rising, increasing the risk of intense storms. CAPE tells us when the atmosphere is primed for severe weather. It's a key reason scientists worry about future supercells. If CAPE is the fuel, wind shear is the engine's spin. Wind shear, changes in wind speed or direction with height, creates the rotation needed for supercells. Without it, storms are short-lived and disorganized. When a strong updraft meets wind shear, it tilts horizontal spin into the vertical, forming a mesocyclone. Wind shear also separates the updraft from the downdraft, letting the storm persist for hours. Strong low-level shear is especially important for tornado formation. Meteorologists analyze wind profiles to assess supercell risk. When high CAPE and strong wind shear align, the atmosphere is primed for severe storms. That's when we issue watches and warnings to keep people safe. Supercells are nature's most organized and violent storms, defined by their rotating updrafts. They produce tornadoes, giant hail, destructive winds, and flash floods. Their formation depends on a volatile mix of instability and wind shear. As the climate changes, the regions at risk are shifting. Central and Eastern Europe may see more supercells, while some areas may see fewer. In North America, Tornado Alley could expand eastward. These changes demand new preparedness and warning strategies. The study of supercells is ongoing. There's still much to learn. Continued research and clear communication are our best defense. I've seen these storms up close, and my respect for their power only grows. By staying informed and prepared, we can all stay safer as we watch the skies of tomorrow.